We originally talked about differentiating the exponential function. Today, we want to make sure we give the rule for differentiating the logarithmic, the natural logarithmic function. All right. So on page 715, we will skip the proof. But anytime we want to find the derivative, we could always go through the good old definition of the derivative function. But we're just going to take it at face value right now. What this says, it says if you have y equals the natural log, ln means natural log. If y equals the natural log of x, and it has these absolute values here, sometimes you'll see them, sometimes you won't when you're differentiating. If this function is what you have, then the derivative, then y prime, is 1 over x. Okay, now let me give you a name for this. There's the name to call this, what you're taking the natural log of, you can call that the argument. It's something we use in trigonometry. It's something, we just kind of need something to say, to call. You know, we had the radicand, we had square roots. The radicand is what's under the square root. Well, here, what you're taking the natural log of, or if you're in trigonometry, then what you're taking the sine of or the cosine of, you can call the argument. So what this turns out to be is, in other words, to say this verbally, the derivative, here's another form of it. Let's do it in this notation. The derivative with respect to x of the natural log of x equals 1 over x. That's what this is telling us on page 715. The derivative with respect to x of the natural log of x is 1 over x. And all the other rules that we've ever known and loved still apply. The product rule still applies. The quotient rule still applies. The chain rule still applies. So let's go back and do a couple examples here out of 11.8. All right. We're going to start with number 30 on page 717. Yes, that's right. That is absolute value. Divided by 3x plus 4. All right. So let's see. We know now we have this new rule that we're going to have to apply that we didn't have before, but if we were to look at this based on what we would do from chapter 2 or unit 2, what rule do we need to use? Right, Gabby's right. We got to use the quotient rule. And with that in mind, the top is 3 times the natural log of the absolute value of x. All right, so that means I have 3 times the derivative, because that 3 is still a constant factor, the derivative of the natural log of x. So it's going to be 3 times 1 over x. So t prime here is going to be 3 divided by x. Okay, I'm going to use the quotient rule, so I'm going to find my top and my top prime, my bottom and my bottom prime. It sounds very unmathematical, but I hope it's helpful, at least to get you some intuition to make these rules easier and more efficient for you to apply. That's probably why they wouldn't put it in a book, because, see, mathematicians are real particular about the way they say things, and so you probably never see anybody write top and bottom in a book, because other mathematicians will say, you can't say top and bottom, it doesn't sound, it doesn't sound sophisticated. But when it's the teacher teaching it, then I can say it any way I want, and hopefully that helps. Top and bottom. It certainly is easier, yes. It's not as much math speaky stuff. The T's and the B's? Or the U's and the V's?
The U's and the V's.
U's and the V's. I think it's very confusing also, yeah. Yeah, I do too. So, all right. So now we're going to be able to find dy dx because we know that according to the quotient rule, it's the bottom 3x plus 4, times the derivative of the top, 3 divided by x, minus the top, 3 times the natural log of x, times the derivative of the bottom, divided by the denominator, bottom squared. Now, we're done with the calculus. The rest of it's a little bit of algebra cleanup that we're going to have to do to match what the back of the book is going to say or what Math Excel is going to accept. We're going to have to do some algebra cleanup. And this particular kind of algebra cleanup requires simplifying a complex fraction. All right. Remember, we had bottom times the derivative of the top. So I have the 3x plus 4 times 3 in the numerator. So it's going to give me 9x plus 12 in the numerator. And x in the denominator. And then I've got the 3 times the 3, natural log of x. And then we call this a complex fraction because we end up with a fraction inside the numerator. We have a fraction inside the numerator. And it did come up for us one time before when we were talking about doing average cost. We ended up seeing something that was sort of a complex fraction. So to simplify this, we're going to multiply all terms in both the numerator and the denominator by x. So I'm going to put it in here in red. X here, and then x in the denominator. And what that will do for us, the effect that's going to have is it's going to cancel these x's here, and it's going to help me simplify my complex fraction. So we're going to go to, let me see if I can have enough room to write this, 9x plus 12 minus 9 times x times the natural log of x divided by x times 3x plus 4 quantity squared. That's what we could end up with for y prime. That is called simplifying that complex fraction. Well, I ran out of time today because I wanted to show you the graph, and so I didn't get a chance to do another example, but you can also apply the chain rule. So you're probably going to have to look at some examples in the book. I know, we just found out the book is not always super great. And it doesn't have very many examples. Well, it does. Yeah, you're going to have to look at example 8. Check out example 8 to help you with some of these homework problems. Okay, Philip. Right here?
No, I know you those counts loud.
Right here? Right. Okay. Well, now this particular term right here was 9 natural log of x, and it didn't have a denominator, so you could think of it as over 1. Maybe that will help. So there's no canceling out here because the denominator here is a 1. So it's just 9 times x times the natural log of x. I just wrote it in between here. This is probably cleaner to write it that way. You don't lose it as easily. Multiplication is commutative. 9 times the natural log of x times x. 9 times x times the natural log of x. Right. It's one term. Correct. It's one term because you have to multiply. Terms are separated by addition or subtraction. So when I saw this one, I had a term. I had to multiply by x. And then I have this one, I have to multiply it by x also. Okay. Okay. All right. I will see you guys on Tuesday.